this lesson, we are going to be studying M&Ms to learn about sample size and frequency. Here's the standard we are learning about. By the end of this lesson, you'll understand that statistics can be used to gain information about a population by examining a sample of the population. Generalizations about a population from a sample are valid only if the sample is representative of that population. And you'll understand that random sampling tends to produce representative samples and support valid inferences. There are two vocabulary words that are going to come up in this lesson. The first one is sample size, which means the number of objects in the portion of the group being studied. We are going to be studying bags of M&Ms, so in this case, sample size refers to the number of M&Ms in your bag, or sample. The second vocabulary word is frequency, which means the number of times a particular value occurs in a set of values. In this case, since we're studying colors of M&Ms, this refers to how many of a certain color you get in your bag. In other words, how frequently that color shows up in your bag. So now I've divided you into pairs and given each pair a bag of M&Ms. Plain M&Ms come in red, orange, yellow, green, blue, and brown. First, we're going to make a prediction. Do you think you will have the same number of each color in your bag? In other words, will each color have the same frequency? Who thinks you'll get the same number of every color? And who thinks you'll get different numbers of different colors? Well, let's watch this quick little video and find out.
Everything has a story, and this is the story of our favorite beloved candy-coated chocolates, M&Ms. It was Forrest Mars Sr., son of the president of Hershey's Chocolate, who we owe the pleasure of the M&M's invention. Mars was visiting Spain during the Spanish Civil War when he witnessed soldiers eating candies that wouldn't melt. 18 years later, in 1941, M&Ms were born. Their home was in Newark, New Jersey, and the original colors were brown, red, orange, yellow, green, and violet. They quickly became popular among World War II soldiers who enjoyed them in their sea rations due to their long-lasting nature. Back then, M&Ms were distributed in little cardboard tubes for packaging. During the war, production of the M&Ms were at 200,000 pounds per week. After the war, this number skyrocketed to 600,000 a week, a 3 times increase from before, and the 1950s saw production hit 1 million pounds a week, a 40% jump from the years before. By this time, the little candy-coated chocolates had replaced their cylindrical cardboard packaging with the iconic brown plastic bag we know of today, and the violet M&M color was replaced with tan. They branded themselves with a little black M, and in 1954, M&Ms were ready for TV and introduced their famous tagline, "They melt in your mouth, not in your hand." The little black M was then changed to white. A surge in production followed, and soon the factory in Newark was too small for demand. M&Ms had to find a new home in 1958 in Hackettstown, New Jersey. M&Ms still call Hackettstown a home today. 1995 introduced a new color lineup in which tan was replaced with blue after a national vote. After this change, the color percentages for distribution were 24% blue, 20% green, 16% orange, 14% yellow, and 13% for both red and brown.
So now we know that the M&M company doesn't make the same number of every color. You can see by this chart, they make a lot of green and blue, but not very much red or brown. So now it's time to make another prediction. Do you think you will have this same percentage of M&M colors in your bag? Will 24% of your M&Ms be blue and 14% of them be yellow? Why or why not? Why don't you think so? Who wants to share their prediction with us? Okay, on your worksheet, there's a chart. You'll see that the frequency percentages published by Mars are already filled in for you. Mars is the company that makes M&Ms. In pairs, you're going to open your bags, count your colors, and fill in the rest of the chart. I already did my own bag, and here's what I got. I sorted the colors, and it turns out I got 9 brown ones. Then I did all the other colors, and this is how they turned out. Then I added them up to get the total. So I have 57 M&Ms in my bag. So go ahead and open your bag and count them out with your partner and fill in that first column. No fair eating any yet. We want the numbers to be really accurate. No cheating. Okay, now I want to know what percentage of my bag is brown. Who can tell me how I figure out what percentage of my M&Ms are brown? That's right. I divide 9 by 57. and I get 0.15789, blah, blah, blah. Don't forget that only gives me the decimal, and I want the percentage. How do I convert the decimal to a percentage? That's right, I multiply by 100, so I get 15.789%. Well, the chart says to round to the nearest whole percentage point, so what would that be? Right, 16%. So I'm going to put that in that column. So now I know that 16% of my M&Ms are brown. The Mars company says that 13% of the M&Ms they make are brown. So how close is that? We take my percentage, 16, and we subtract their percentage, 13, and we get 3%. There's a 3% difference between what Mars says they make and what I actually got in my bag. Okay, so now it's your turn. Go ahead and work with your partner to fill in the rest of the chart. So how did your bags turn out? Did anyone get exactly what Mars said we would? And who was way off? Who got a way different percentage? So here's the big question. Since nobody got exactly what Mars says they produce, why do you think that is? Does anyone have an idea why our frequency isn't quite the same as the frequency of colors that Mars produces? Here's a clue. What was the other vocabulary word I mentioned? We did frequency and sample size. Do you think sample size might have something to do with it? Maybe the size of the sample might affect the frequency? What if I only gave you 3 M&Ms? What would that do to your percentages? So if sample size is the secret to getting more accurate percentages, what could we do differently in this experiment to try to get closer to the published M&M frequencies?